Hello ROS developers and welcome to this live class number 105, where we are going to be talking again about ROS2 and specifically about topics, how to create publishers, subscribers, some command line tools in order to work with topics. So let's start. Hello ROS developers again, my name is Alberto and today we are going to be doing live class number 105, and as I have just said a few seconds ago, we are going to be talking about topics in ROS2. So how can we publish into a topic, how can we subscribe to a topic? In this case we are going to be creating programs in Python, so we are going to be programming in Python. Also we are going to have a look at some command line tools that can help us debug issues when working with topics in ROS2. So yeah, welcome everybody. Let me have a quick look at the chat to say hello to everybody and make sure that everything is fine. Hello ROS developers. Go ROS. Hello Felipe Rivas, Der Capute, Vishal, Magfoot. Hello everybody. J. Carroll, I can see also. Mikael Tracy, hello everybody. So yeah, let's start. Then, as always, I'm going to start by sharing with you guys the project of this live class. Yeah. So everybody, logging into your accounts in ROS.ds. If in case in the very rare case that you don't have an account yet in ROS.ds, just create it. It's completely free and it's going to take you just a few seconds. So create it and log in. And then I'm going to jump straight now to my PC screen. But before that, as always, I'm going to get a bit of energy from my ROS Developers coffee. There we go. Now I'm ready to start. So let's go. All right. So here I am in my screen. Then I'm already logged in the ROS Development Studio, as you can see, and here I have the project I have created for today's live class, for live class number 105. So I'm going to right now grab here the link and paste it here to the chat. Let's go. So now, what you have to do? Well, all you have to do is to click on the link or copy paste this link I have shared in the channel into the URL here in your browser, and then you're going to automatically get into your workspace, into your project section. You're going to get this project for live class number 105. Yeah. Then once this is done, we are just going to click on the open button and open project. Yeah. So let's click here, and then this might take some time in order to load the whole environment. As you can see, we are going to load an environment where we have Ubuntu 18 plus ROS2 Eloquent. Yeah, so this kind of environments maybe take a little bit longer than the regular one with Ubuntu 16 and Kinetic, but it can take at like maximum 2 minutes or something like that. So let's just be patient, and meanwhile I'm going to talk a little bit with you guys, as I always do. So I have very fresh news for you guys. As always, these news come from our academy. So as you might already know, we have here from the ROS.ds screen, you can access to our academy here, clicking on the ROS courses button. And this is going to take you to our academy, which, by the way, it has been renewed a few weeks ago. As you can see, it's looking super nice, the new environment, and it's going to keep getting better each day. We are adding improvements each day, and yeah. So we have published already last week, Friday. We published 2 new courses, which are the Kalman filters course, super interesting course. I really encourage you to have a look at at it. It's super interesting, and it's going to help you understand how Kalman filters work and how you can apply them to real practical robotics projects, especially in terms of robot localization, in order to improve the localization of your robot. Super interesting course. So I really encourage you to have a look at it. And also, besides the Kalman filters course, we also published the Robot Dynamics and Control course. So 2 brand new courses, which are, as you can see, are focused a little bit more on robotics theory, but always applying this theory to ROS projects, to ROS projects with gazebo simulations. So you are going to learn the theoretical concepts, which are extremely important, but always you are going to learn them and apply them to practical examples, in this case to simulated examples using gazebo and ROS. So also super interesting course in order to better understand the robot dynamics, how the dynamics work. Also a little bit of feedback control, as you can see. Here you can have an extensive look at the different contents and units of the course. So super interesting course as well. I really encourage you to have a look at it. And also, this week is going to be published the Basic ARM Kinematics course. And also very soon is going to come a ROS2 navigation course. So how to make autonomous navigation using ROS2. Also super interesting and super important course, which is going to be coming very soon, and which is basically one of the reasons why we are trying to focus these last live classes more into ROS2. We are going to keep doing ROS2 content. We are also working on preparing the ROS2 Foxy computers. So ROS2 is gaining each day more power, and it's going to keep being like this. So I think it's time now to start learning how ROS2 works and to start getting practice on this subject, because this is something that is going to give you guys advantage over other people. So the sooner you start learning and the sooner you get used to work with ROS2, the more advantage you are going to have over other developers. So guys, let's go back here to the project. Excellent. So as you can see here, I have already my environment loaded with the notebook here for today's live class, ROS Developers live class number 105. I never get used, by the way, to this image. It's really ugly. I think for next live class I'm going to work in order to try to change this image, because every time I see it I get scared of myself, honestly. So okay, so yeah guys, let me know, have you already loaded your projects? Are you in the same point as I am? Do you have your projects loaded? Yes, no? Let me know in the chat here. Where are you from, Sir? Alex Hoang. I am from Barcelona, Spain. Hiep, where are you from, by the way? Hiep Hoang? Where are you from? Asia, I suppose, by the name? He's from Italy, says Misho. I don't know if you are referring to me, Misho, but I am not from Italy. I love Italy. I have family in Italy, by the way, but I am from Barcelona, from Spain. Are these new courses paid? Asks Murugesh. Yes, these new courses, you can access them under the subscription. So you need to have the subscription to our academy. These ones are not free. We have also free courses, which I can show you now, by the way, but these courses I am showing now are go under subscription. Loaded, yes, still loading, says J. Carroll. No problem, just it's going to I'm going to wait maybe a couple of minutes more. Mexico, Felipe Rivas is from Mexico, from Algeria, Mahfoud, from Thailand. I'm sorry, don't worry, Misho, don't worry. Okay, load it. Excellent. So everybody is starting to load their project. So by the way, what I'm going to do now is to start setting up the environment. Yes, because one thing is to load here the project, as I do. So now I have my computer started, let's say. I have automatically here opened the project so that I can follow here the instructions that I'm going to find here. But the next step now is to set up the environment. So today we are going to be working on a gazebo simulation, which works with ROS2, by the way, and it's a Turtlebot 3 simulation. Yeah. So in order to start the simulation, you have here some commands and some instructions in order to load it, to start it. So I'm going to start doing it. Yes. So everything I am doing here, in case you get lost, guys, is to follow here the instructions. Yeah. So first of all, I'm going to source the ROS version that I want to work with. In this case, today we are going to be working with ROS2 Eloquent. Therefore, I need to source the Eloquent installation. Yes? So I'm going to source the Eloquent installation so that I can start using ROS2 commands. Next, I'm going to source the simulation workspace. Why? Because in this workspace is where I have all the simulation related packages, all the packages in order to start the Turtlebot 3 gazebo simulation. So I need to source this workspace as well. Yeah. Then let's source this workspace. Now I need to set up some environment variables related to gazebo in order to properly be able to load the models of the robot. So I'm just copy pasting these commands here. As you can see, I'm just exporting some environment variables related to gazebo, and final variable is the Turtlebot 3 model. So basically I'm going to set here that I want to start the waffle Turtlebot 3 model. Yep. So now what I need to do is to come here and actually launch the simulation. So this is done with the following command: ROS2 launch Turtlebot 3 gazebo, and the launch file, which is emptyworld.launch.py. So I'm going to execute this command, and it is going to start loading my simulation. And in order to see if it works, because it can happen, so it's possible that sometimes the process doesn't work properly and the simulation doesn't get loaded properly, as we already saw in last week's live class. So here we can see that the commands are starting. Don't worry if you see some errors like these ones; they are expected. Don't panic; it's normal. So these errors are normal. Then, in order to see if it works, what we need to do is to open here a gazebo window. Then, if it works, I should get here loaded the Turtlebot 3 simulation, and I should see something similar to what I have here. Yes, an empty world here with the Turtlebot 3 waffle loaded. Then, as you can see in my case here, it looks like it's not loading. I'm going to wait a few seconds more to see if it loads, because sometimes it can take some time. But it looks like it's not properly working. So all right, guys. So in case this happens, well, let me know in the comments if this is happening to you as well, or in your case it has loaded. Okay, loaded. Thank you. Practice while learning. This is the key to deep learning. It has loaded. Okay, so for kernel it has loaded. Yeah. So as I was expecting, probably for some of you guys the simulation is going to load properly, but for some others it's not going to load. Like this is my case. It hasn't loaded, as you can see. The screen here remains black. So what to do in case this happens? Okay, then we have here the steps, summarize it, but I'm going to do it myself and explain more in detail. So in case it doesn't load, like it has, if the simulation has loaded, don't touch anything. Yes, just leave it like it is. You have the simulation loaded, excellent. Then you just have to wait until we keep progressing. But for the ones who the simulation hasn't loaded properly, like my case, let's do the following. So I'm going to stop the command here where I did start the gazebo simulation. I'm going to stop the command here with Ctrl+C, and then what I'm going to do is to use the ps faux command. Whoops, sorry. ps faux command in order to find the process where GC server is running. Why? Because even though I have terminated this process with Control-C, the GC server process that I have started with this command is still running there. You're going to see it here, you see? So the first process, the first GC server that I see here, this just ignore it, it doesn't matter. Then the important one here in this case, it's this second one. Yes? This, as you can see, it's the process which is trying to load the Turtle3 gazebo simulation. Yes? We have it here. So I need to execute this command in order to know the PID, the process ID number of the GC server process. In this case, the PID, it's this one. In my case, it's 2975. In your case, probably the number is going to be different. Yes, but in my case, it's 2975. So once I have identified this name, I need to kill this process manually by issuing the following command: kill -9 and then the PID number, which in my case it's 2975. Yes? Then if I execute this command and I look again for the GC server process, I'm going to see that it is gone. Yes, we have this one, which it doesn't matter, but the actual real process, which is this second one, it's not there. We have killed it with the kill command. Yeah. So now, once we have killed the command, we have to relaunch the simulation like this, and now this time it's going to properly load the simulation. You can see. So now the simulation is properly loading. Yes, this happens sometimes. Probably some ROS2 issues that still have to be worked around. But as you can see now, the simulation has loaded perfectly. So here I have my gazebo empty world in this case, with the Turtlebot 3 waffle model here in the middle. Yep. So I want you all guys to be in the same point as I am. Yes. So I need you to, all of you, be with the ROSject loaded as I am here, the notebook opened here, so that we can all follow the instructions stated here in the notebook, and here at one side the gazebo simulation loaded. Yes, so I need you, all of you guys, to be at the same point as I am here. Let me know if you are all set up. It has loaded, working, still trying to load. Queue limit reaches warning. Work. What is GC server and why do we need to kill it? Very good question, engineering. Mechatronica Maxima says that it worked. Okay, so what is GC server and why do we need to kill it? Okay, so so whenever we start a gazebo simulation, yes, you all of you probably have already worked with gazebo. Yeah, it's a simulator. So whenever we start a gazebo simulation, basically we have two processes that are started. One is the GC server. The GC server is the process where all the let's say all the mathematics are performed. Yeah, so in the GC server, all the code is running and all the physics are being processed. All the heavy load is being calculated there in the GC server. Yes. Then this is one process, the GC server. Then on the other side we have the GC client, what is known as the GC client. The GC client is the process that shows us graphically the simulation. Yes, it loads the proper meshes so that we can see actually the robot as we see it here. Yes. Does it make sense? So on one side we have the GC server, the server, where all the physics and everything is being calculated, and the other side we have the client, which is in charge of the GUI of showing and displaying the actual simulation, the world elements. Yeah? Then, in our case, we are working on a web. Yes? So in our case, the GC client is substituted by GC web, which is basically the same as the GC client, but based on a web browser. Yes? So, whenever we start a gazebo simulation and we kill it, in this case, as you saw, the GC server process was still running there. So we actually, so the visual part, as you saw, the visual part was not properly working because we weren't seeing the robot. So basically, we stopped the process, but the GC server was there running on the background. So we needed to manually go and kill it so that we can start again the gazebo simulation. Because if we kill it and we try to start again a gazebo simulation with an already GC server process running on the background, we are going to get an error. It's going to say, hey, you cannot launch a gazebo simulation because you have already a GC server running. So that's why we needed to kill it. Yes, this is summarized more or less what we did. I cannot go much more into details because it goes out of the scope of today's live class. So basically that's it. All right, working, loaded, thanks, loaded successfully. Okay, then let's go. Let's start. Let's start with it. All right, then once we have this working, we can minimize this shell and start with the class. So we are going to start with the publishers. Then the first thing we are going to do is to open a new shell. So we are going to work with a fresh new shell. Let's open it here. And also we are going to open an IDE so that we can visualize all our files and packages in a graphical way. Yes? Then the first thing we are going to do is to source ROS version, as we did before. We need to source ROS Eloquent so that we can use ROS2 commands. So this is the first thing to do. There we go. Next thing, we are going to create a new Python package. As we learned from the previous live class, we need to create new packages always inside the SRC folder of our workspace. So we are going to go here to the SRC folder of the ROS2 workspace, and inside here we are going to execute the command to create a new Python package. In this case, I'm going to create a new package which is named my publisher. The build type is Python, and as dependency I'm going to indicate RCL-Py. There we go. So I'm creating my package, and next thing I'm going to do is to create. I'm going to come here to the IDE, and my new package is going to appear here. We're going to see it here inside the SRC folder named my publisher. So now inside the my publisher folder here, besides the init.py, I'm going to create my new Python script which I'm going to name publisher.py. There we go. And inside this script I'm going to copy and paste the code I have here in the notebook. Yes, so this is the Python code for a publisher. So I'm going to copy, Ctrl+C, and paste here into my file the code. Yeah, so here I have it. Then as you can see here we have a simple Python code of a class. So first of all we are importing RCL-Py, which we needed in order to create ROS2 programs with Python. We are importing, as you can see here, the node class and the twist class, since we are going to use them. Then we create a class named LC Publisher, which depends on the node class, yes, which is the one that we have imported here. Then we declare here the publisher with the create publisher keyword. This is used in ROS2, which is going to use the twist type of message. Yes, probably you already know this type of message from ROS1, and we are going to be publishing onto the command vel topic. Yeah, make sense? Then we set up a timer, which in this case is going to be of 0.5 seconds for our callback. Yes, we create a timer here with 0.5 seconds as timer period, and we define a callback for this timer. Yes, here we have the callback, and then inside the callback, which is a function of the class, we are setting the values of our twist message. In this case, we are setting 0.5 meters per second to the linear x velocity, and 0.5 to the Angular Z component. Yes? Then finally we publish the message. So we populate the twist message and we publish it. Then we have the main function here, where we are initializing our class. We have a spin here so that the program doesn't end until we end it by Control-C, for instance. And once we close it, what we are going to do is to destroy the node and shut down the RCLPy module. Yep. Does it make sense? Then, what we need to do now? Now what we need to do is to do the proper modifications to the setup.py file in order to compile our program. So, for this, basically what we need to do is to add the following line into the console scripts section here at the entry points argument. Yeah, so we come here to the entry points, and inside the console scripts, here I'm going to paste the following line. So this basically is saying that I want to create a new executable node, which is going to be named publisher underscore node, and I want to generate this executable from the main function, which I have here, from the main function, which I have defined here, which is inside the publisher program, publisher.py program, which is this program I have here, yes, which is inside the my publisher folder. We have it here, yes. So my publisher folder, inside we have the publisher.py script, and inside the script the main function. So from this I'm going to generate an executable node, which is going to be named publisher node. Yeah. All this we already talked about it in the last week's live class. All right, so what to do now? Well, what I need to do now is to compile. So always remember, we need to compile from the root of our workspace. Yes, not from the src folder, but from the root. So now I can execute the call compile command. This is going to start compiling my package and generating the executable node. And now, what I can do is to, for instance, run my node with ROS2 run my publisher, which is the name of my package, oh sorry, I forgot to do one thing. Do you know what I forgot to do? So I compile it, and what else should I do that I am not doing? Can somebody tell me in the chat? Misho says that the IDE is not loading. Okay, Misho, try to refresh it, clicking here in this refresh button, reload button. Try to reload it like this. Source it, source. Okay, very well, guys. So I need to source, because I have compiled it, but in order to get the latest changes, I need to source the setup file, which is inside my install folder. So I'm going to source here everything. So now I'm going to find without problems my package and my node. So ROS2 run my publisher. I'm going to autocomplete everything, and the node was named publisher node. So here I have the command. Then once I execute this command, this program, which is my publisher, should start publishing messages into the command belt with the following velocities: 0.5 in the linear x-axis and 0.5 in the angular z-axis. Yep. So the robot should start moving in a circle-like movement. So let's run our program and see if the robot indeed starts moving. And okay, so we are getting this error also. Don't worry, don't panic. In case you get this error, just come here to the end of the live class, to these notes that we have here, and copy and paste the following command. Here in the notes, yeah, at the end of the subscriber section, here, you're going to find this export command for the Python path environment variable. So just copy and paste this command. This is going to properly set up the Python path variable. And now we can run again the program, and it's going to work without problems. There we go. So there we can see the robot, how it starts moving. Yeah. All right. So far so good. So what else? Okay, I'm going to stop here my program, and the robot is going to start to keep moving. Yeah. So why does this happen? Well, this happens because the topic is listening to the last message which was published into the topic. But don't worry, we're going to get there in a moment. So for now, let's just keep advancing, and we will leave here the Tatable3 robot doing circles. It doesn't matter. Okay, so super simple, as you can see. This is the basic template code that you can use in order to write a ROS2 publisher. Yes, as you can see, super simple. Then let's go for the subscriber. So from one side, we can publish into topics. We can publish messages into topics, like we are doing right now. We are publishing messages into the command bell topic in order to move the robot. But on the other side, we can also subscribe to topics in order to read the messages that are being published into a certain topic, right? And my robot is going there, moving in circle. Okay, so let's now create a package and create a Python script to subscribe to a topic. So let's come back to the shell. Here we have it, and in this case I don't need to source again because I have already sourced this shell, so I don't need to source again. So what I'm going to do is to directly create the package for my subscriber. So inside the SRC folder, I'm going to paste this code, and I'm going to create a package. In this case, it's named my subscriber. Again, it's an amend Python type of package, and as dependency rcl-py. So here I have my subscriber package, and in this case here I have the code for the Python subscriber. So I'm going to copy it. I'm going to come here to my subscriber, create the subscriber.py Python file, and I'm going to paste the code here. Yes? So what do I have in this code? Let's have a look. Super simple, again, as you can see. So again, we are importing rcl-py, we are importing the node class, and we are importing the twist class. We create the LC subscriber class, which depends on the node, inherits on the node class, super class in this case. And here is where we are creating the subscriber. Yes? So create subscription, and we paste the following arguments. Twist. So this is the type of messages that I'm going to be subscribed to, that the topic that I am expecting to read from this topic. Yes, so I'm going to subscribe, in this case, to the command bell topic, and I am expecting to receive twist messages in this topic. Yes, then we have to declare again here a listener callback, as we can see here. Yeah, here we have the queue size in this case. Yes, so the listener callback, it's defined right down here. Then in the callback function, what we are going to do is to just print the following message: I heard, and we are going to print the twist message that I am reading. So what is going to happen here? Well, each time a new message is published into the command bell topic, this callback function is going to be triggered, and therefore this message is going to be printed. Yes? So each time a new message is published into the command bell topic, the callback function, which in this case it's this one, is triggered. Yeah. Then down here we have the main function where we are initiating the node, we are initiating the class, we have here an spin so that the program doesn't end, and finally we have the destroy node function and shutdown functions, so that when we stop the program manually, for instance by pressing Ctrl+C, we are going to destroy the node and shut down RCLPy. Yeah? Shut down our node. Yes, makes sense? Alright, so as you can see it as well, super simple code, template. Yeah? Then, again, what are we going to need to do? We're going to need to compile it. So let me copy this line here again. I'm going to come to the setup.py, and inside entry points console script, I'm going to add the below line. So I'm going to generate an executable node named subscriber node, which is going to be generated from the main function, which I have here, from the main function of the subscriber.py script, which is this one I have here, which is inside the my publisher folder, as we can see here. Yes? And from this, I'm going to generate an executable node, which is going to be named publisher node. Yes? Alright, so let's come back to our shell and let's compile, call combuild. There we go. Let's source. I don't want to forget about the sourcing this time. Setup.bash. And now what I can do is ROS2 run of my publisher, which is the name of the package I have just created, and publisher node, which is the name of the executable I have just generated. So let me run this, and in this case I am not getting any message. So I was expecting here to get messages of this form: I heard and a twist message, but I am not getting anything. Does somebody know why? Why I am not reading anything? Why is it that I am not reading any message? Export worked. Robot is moving, says Engineering Nation. Gloria is asking, hi, what is... Okay, I see that engineering is already answering. As for PS Fox, grep GC server. Okay, I see that everything is solved. Thank you very much, engineering, for helping me answer some of the questions. Paul Babish is saying, can we create a subscriber publisher class in ROS1? What do you mean, Paul? A subscriber publisher class in ROS1? So are you talking about ROS1 or ROS2? Well, do you mean having a publisher and a subscriber in one same class? In that case, yes, it's possible. So here I have created different programs and different classes for the publisher and for the subscriber, but you can have a publisher and a subscriber in the same class, no problem. Either in ROS1 and in ROS2. In both versions you can do that. If we have time, we can do it later if you want, guys. We can create a program where we have a publisher and a subscriber together in the same Python class. Mikhail Tracy says, because we are not publishing. There we go. We are not publishing. So actually, we are not publishing any message into the topic command bell. Therefore, I am not being able to read nothing. That's it. Yes? So, how can I know this? Okay, let's first of all have a look at some command line tools that we can use in order to debug topics. So I'm going to open another shell, yet another shell, because I want to leave here the subscriber running. So what can I do? Well, first of all, what do I have to do first of all? Because if I run directly this command, what is going to happen? It's going to work. Let me try it. It's not working. ROS2 command not found. Why is not working? What do I need to do so that this command works? Why it's not working? Did my shell crash or something? Can somebody help me on this? Source ROS2. There we go. Okay, so we need to source ROS2 before starting to use ROS2 commands. Yes? So source opt ros eloquent setup.bash. There we go. So now we can use the ROS2 topic list, which is going to generate a list of all the topics that are currently available. Yes, we can see here some topics for the camera, clock, command bell, EMU, joint states, ODOM for the odometry, scanner, the TF. Yes, so here we see all the topics that we have currently available. Yes, and between them we can see the command bell topic. Yes, this command what does basically is to, from the word list of topics, which is this one, we filter for the command bell word string. Yes, then this is going to show me only the command bell topic. Yes, so we have the ROS2 topic list, which is going to give us a list of all the topics available. Then if we are interested in a specific topic, we can use the ROS2 topic info command. Yes, so ROS2 topic info and the name of the topic which we are interested. In this case, it can be command bell. So what can I see here? Here I can see that I have the geometry messages message twist. So this topic uses the command bell, this topic uses the twist message, as we have seen. Yeah, so when we publish it into the topic, we use the twist message, and when we subscribe to the topic, we were using as well the twist message. So we can confirm that this topic uses this type of message. Yes, the twist type of message. Then we can see here how many nodes are publishing into this topic and how many nodes are subscribed to this topic. Yes, in this case we have 1 and 1 because as publisher we are still counting the publisher that we run before. Yes, actually this is not exactly correct because we are currently not we are not really publishing anymore. In let me see. It shouldn't show there as a publisher, in fact. But in oh, see, I can see that we have the publisher here. Oh, of course. So here we have the publisher running, which doesn't make any sense. Okay, let me stop it. So we were running the publisher instead of the subscriber. Yeah. Okay, ROS2 topic info command bell. Okay, this makes sense now. Yeah, so we don't have any publisher and we have one subscriber. Who is the subscriber? Our program is not the subscriber because we are not running our subscriber node, right? We are not running it. So the subscriber, in this case, the subscriber is Gazebo, is the Gazebo simulation. Yes, the Gazebo simulation. Where is my robot? Here, it's going far away. So the Gazebo simulation is actually listening to this command bell topic. Why? Because every time a message is received, is published into the command bell topic, then Gazebo is going to get this message and convert it into wheel velocities so that the robot starts moving. Yes, this is why we have one subscriber here. Yes, so now indeed if we run our subscriber node, which is what I wanted to do before, subscriber node, nothing is going to happen anyways, because we are not publishing any message, so this is alright. But now here a new subscriber should appear. See? So now we have two subscribers. We have this one, which is my program, and Gazebo, which is the other subscriber. Yes? Alright. So what else? What else? We have the ROS2 topic echo command. So this topic, what it's going to do is to generate a subscriber from the command line tools of my topic. So ROS2 topic echo of command bell. This, what it's going to do is to subscribe to the command bell topic and start listening to its messages. So basically this is doing the same as this. Yeah? So here we are subscribing from the command line tools, and here we are subscribing from a Python script. But basically it's the same. In fact, if I open a new shell and I source opt ROS eloquent setup.bash, oops, this is wrong, source. If I source and I do a ROS2 topic info, I should get 3 subscribers now, right? So ROS2 topic info command bell. So now I should get 3 subscribers. There we go. So the subscriber count, we have 3. One is Gazebo, second one is my Python script that I'm executing here, and the third one is this one, which I have started from the command line tools. Yes, so I'm going to stop now this one, and this is going to go back to 2. Yep, there we go. Alright, so with the ROS2 topic echo command, what we are doing is to basically generate a subscriber from the command line tool. So we are subscribing to this. In any case, we are not seeing nothing because we are still not publishing nothing. Yes, so in case we had some messages, we would see something similar to this. So what can I do now? What I'm going to do now is to publish from the command line tools using the ROS2 topic pub command. So let me open a new shell here. In fact, I should have left that open there. Source opt ROS eloquent setup.bash. There we go. And now I can use this command here, ROS2 topic pub, in order to publish a message into a specific topic. In this case, I'm going to be publishing a message into the command bell topic. Yes, so ROS2 topic pub from publish once, because I want to publish only one message. I'm going to publish a single message into the command bell topic. Then the message I'm going to publish is going to be of the twist type, and it's going to contain the following information. So the velocities are going to be all to 0. So basically what is going to happen is that the robot is going to stop moving. Well, at least this is what should happen, yeah? So let me come here and execute this command and see what happens. Actually, there's been a problem here. Oh yeah, I think it's because of this. So let me properly copy here the message. Yeah, there we go. So this, the format got, this was by mistake like this. So let's just put it all together like I have just done, and let's publish the message again. There we go. So I have published the message and the robot has stopped moving. But not only this, I have published one message into the command bell topic. So if I come here to the shell where I had the ROS2 topic echo command bell running, I can see that one message was published with all the velocities to 0. And if I go to my program, I can see as well a message indicating that he has heard the twist message that I have just published, but only one. Why? Because I have used the once argument, so that I have only published one command. Can I publish more than one? Yes, of course, I can. For instance, if I use ROS2 Topic Pub -h, I'm going to get help on this command, and it's going to show me more options I have. Yeah, so here I have different options I can use on this command. For instance, there is one which is rate, which is going to allow me to publish at a certain rate in hertz. Yes? So, if I come here and I change these ones for a rate, for instance, let me set a rate of 1 hertz. And I'm going to change the velocities as well, so that the robot starts moving at 0.3 forward, and in angular z 0.3 as well. I'm going to set here, so I'm going to start moving the robot again. And I'm going to publish this message at a rate of 1 hertz, so 1 message per second. Yes? Let me execute this command. The robot is going to start moving. Here I can see it, and in my subscriber program I can start getting messages here, 6, 7, 8, 9, 10, 1 per second. And as well here in the shell I can start reading and seeing all the twist messages that are being published into the topic. Yes? And this will go like this. Sorry, this is the subscriber messages, and this is going to be like this until I stop the program, and therefore I'm going to stop receiving new messages. Yes? Make sense? And now let me publish again one message to stop the robot here with the velocities to 0. There we go. Alright, so let me get a drink. Alright, so 5 minutes left of the class, and I think we are going to make it on time. So basically we have covered almost everything. We have seen how to create a subscriber with Python code, how to create a publisher with Python code, how to work with the most basic and most important command line tools for debugging topics, and finally I want to add here an extra thing in order to complete this live class, which is the how to use the on shutdown method. This is not directly related to topics, but it's very useful in this case, because as you have seen in the case of our publisher, when we stop our publisher, the robot keeps moving. Yes? And this, at least for me, it doesn't make many sense. I want that if I stop the program, my robot stops. Yes, this makes more sense for me, and it's more secure. Yes, so in terms of security, for me, it's better to make the robot stop whenever I stop the program, or whenever the program crashes, for instance, whatever. So for this, we can use the on shutdown method. Yes, this is more related to nodes, but I wanted to add it here. So we can use the on shutdown method. It's possible to call the on shutdown method in order to perform some action before terminating the node. Yeah, so when we are going to shut down our node, we can call this on shutdown method in order to do something. For instance, stop the robot. Then for doing so, what we need to do? Well, first we need to find a new function, which I'm going to add somewhere here below. For instance, I'm going to add, and I need to proper indentate this, by the way. There we go. Super important in Python, the indentation. Yes, so make sure that your indentation is properly set here in the function. So I have added here a new function which is called on shutdown, where basically what I'm going to do is to define a twist message with the velocities to 0, and I'm going to publish this message so that the robot stops when I decide to shut down my node. Yes? But I need to do something else. So I have defined my function, but now I need to set this function. I need to relate it to the node. So I need to add basically this here. I'm going to come here to the spin. I'm going to comment this line. I'm going to comment it. Sorry, let me come here and comment this line. There we go. And I'm going to add here instead the following. This is a snippet of code that I have here. I'm going to add it here. Again, the indentation is wrong, so I need to indentate this properly. There we go. So basically what I'm doing here is to set to the RCL-Pi node that I have started here. I'm saying that the onShutdown function that I want to use for this node is the function, the onShutdown function from my LC Publisher class. Yes? See? So from the LC Publisher class that I have here, I have initialized it here, I'm selecting the onShutdown function, which is this one here. Then I am setting this function to be called whenever my node, whenever my RCL-Pi node is shut down. Yes? So when I shut down, well, yeah, these names, it's a little bit confusing. Let me call this onShutdown method, for instance. And this is going to be so that the names are different. If not, maybe you can be confused by the two. Yes? So this is the onShutdown function method of the node. Yes? And this is the onShutdown. This onShutdown method is the method of the class I have created here. Yes? Then basically, I am saying, hey, when the onShutdown method of the node gets called, so when I terminate this node, I want to call this function, the onShutdown method function, from the LC Publisher class. Yes, this is what I'm saying here. And then I need to wrap here the spin. Yeah, here we had it like this. Now I need to wrap this spin inside a try except in order to catch the keyboard interrupt exception. Yes, this is a bug. But otherwise, I would get this keyboard interrupt error. So this way I'm going to overpass this error. Then now I can save this. Let me test it real quick. Well, let me stop all this. I don't need it anymore. Let me stop all this. Well, yeah, I'm going to leave. Yeah, let me stop this. And now I can compile. In fact, let me open here very quick a new shell and do I'm going to do an echo to the topic to see exactly what happens. Yeah, so ROS2 topic echo command bell. So this way I'm going to see exactly what happens here in the command bell topic. Then I'm going to source here my workspace and I'm going to start my new publisher, which I have created. Publisher node. There we go. So now I'm going to start publishing messages, velocity messages into the command bell topic. I'm going to see them here. And the robot is going to start moving, as we can see. But now, when I stop my program, let me stop it now with Control-C here. Okay, yeah, there's one thing, there's one more thing we need to do. So, let me do one thing here super quick in order to stop. The robot from moving. Okay, and also let me clear this. I forgot about that. ROS2 topic echo. Okay. So there's one more thing we need to do. So here it says, hey, try to use a handle that has been destroyed. Yeah. So here we need to also comment here's the destroy node. Yes, we need to take this out because otherwise there are conflicts with the destroy node. So let me comment this, save, and I'm going to compile again. Colcon build. Install setup.bash. There we go. And let me run again my publisher. There we have it. So the robot should start moving again. There it goes. I should be getting here the messages. And now, if I stop here my program, I'm still getting errors here. Okay, let me see. Failure to publisher's context is invalid at, let me see. Let me have a look at this. Get the default content on shutdown method. Yeah, I think this is right. Publisher. Actually, let's see if I have something wrong here. Let me name this as it was. RCLPy, get default context on shutdown, LC publisher on shutdown, LC publisher, keyboard interrupt. Yeah, I think this is looking okay. Let me try compile again. Source, okay. Publisher. No, I'm getting this strange error. Okay, never mind. Let's just I will debug it now once the class finishes. Try to use handle that has. Oh yeah, now it's complaining about the. Now it's complaining about the destroy node, which I haven't commented. Let me do one last try. One last try here. No, I'm getting this error. Okay, never mind. So yeah, I will have a look at this now, and I will fix it once it finishes. I will see why I'm getting this strange error. It's really strange. Okay, so well, anyways, never mind. We covered the main things with the ones which were actually related to topics. So far so good. Let me have a quick look here at the chat. Source ROS2 source. Okay, I can see everybody here answering to the question I did before. Gazebo simulation. Hola, says Paliloigi. Hello. Hola, Paliloigi. Indent. Once. Great, that good source for dev robot that intermix ROS1 and ROS2 and send command via ROS bridge between ROS1 talker and ROS2 listener. Yeah. Yes. Well, I didn't understand your question, but anyways, we are going to probably do a live class covering ROS bridge, which is super interesting, in order to publish messages from ROS1 to ROS2 and vice versa. So yeah, probably one of the next live classes it's going to be about ROS bridge. So stay tuned. Anantasak, could you please teach how to code SLAM algorithms rather than just using existing packages? Could you please teach how to code SLAM algorithms rather than just using existing packages? Titan Robotics is asking. That's a very, very interesting suggestion. Indeed, Titan. And yeah, so we are working on some courses. Some of them they are in preparation, which are going to attack more the algorithms rather than using ROS packages. Yeah, so we are going to focus more on the theoretical part, on the algorithms, as you say. For instance, we are preparing a course on path planning where we are going to be attacking these algorithms, all these A+, Dijkstra, virtual potential fields, etc., but more focused on the algorithm part, always keeping our ROS practice, which we think it's important to always practice what you learn into something, into a real project, let's say. But yes, Titan, that's a very nice suggestion, and indeed we are already working on this stuff. So ROS bridge would be great, says Gloria. Yes, so ROS bridge, we are going to have for sure a live class on ROS bridge. Do to make robot on previous with ROS1 and connect them with ROS2. Yeah, so Anantasa, with ROS bridge, is it possible to use a simulation, for instance? We will do it. So we will start a simulation which works in ROS1, and we can create a ROS2 publisher, for instance, and with a ROS2 publisher we can publish into that simulation which works with ROS1. This is something that you can achieve with ROS bridge. Have you done a class on Movie 2 for ROS2? Not, Zach. We have not done a class on Movie 2 for ROS2, but we will prepare one for sure. So yeah, in the following weeks we will have a class on Movie 2. And for navigation stack for ROS2, we already did some classes of that, of the navigation stack for ROS2, and we are going to publish also between this week and next week, we're going to publish a complete course on ROS2 navigation. So stay tuned, Zach, because a course on navigation for ROS2 is coming. And if you check our channel also, you're going to see that we already have some live classes on navigation for ROS2, on mapping, localization, and even path planning, I think. And for Movie 2, it's going to come also soon. Can a publisher get a feedback whether the subscriber received the data before the publisher? Can a publisher get feedback of whether the subscriber received the data before the publisher could publish the next message? Paul Pavish? Well, yeah, I think that could be. The publisher will continually publish the message. So placing them. That's indeed not going to be easy to achieve, Paul. But can a publisher get a feedback of whether the subscriber received the data before the publisher could publish the next message? I know there are some functions there that you can use, especially in ROS1. In ROS2, I don't know so much about it. In ROS1, there are some functions that you can use in order to check the connections between the publishers and everything. But in ROS1, I really don't know the status of this, but that's interesting to know. So yeah, let me do some research on that. I see Benjamin Max, it's here answering. We can check while receive the message. I think it's possible in the DDS API, but don't know if it is exposed in ROS2. Yeah, so probably, by the way, we are also probably going to do a live class on DDS. We already did one, but probably we are going to do another one on DDS because this is super interesting, in fact. Maybe a service can be useful in this case. Yeah, probably, Mikael. Probably, yes. Also, we are going to do some live classes about services, service clients, and servers. So yeah, probably in fact, probably next week, I think we could do a class on services for ROS2. What do you think, guys? I think that would be a good idea to do services. Since we have covered more or less topics, we can go to services next week. I think that could be interesting. Or maybe we could also do how to create custom interfaces, custom messages for ROS2 as well. That would be interesting. I don't know. I will think about it and we'll see. So yeah, guys, let me go. Already 15 minutes past the finish time. So I think it's time now to end this. Alright, so thank you very much, guys. I hope that you have enjoyed this live class. I hope that you've learned something new. This is the most important for us, that at least you can grasp some, even if it's a small thing, you can grasp some knowledge from these live classes. So thank you very much for being here with me this hour. And I will see you next week with more ROS2. So until then, stay safe, super important, stay safe, and keep pushing your ROS learning. Bye-bye. What are you doing, Alberto? I'm training this intern with ROS. Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises, a fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.